Okay, now we're going to move on to a more sure method of solving systems of linear equations called the substitution method. You can read the steps here, but I'll just go through the solution here. So let's take a look at this first example. 2x plus y equal 8, x plus 3y equal 9. What we want to do is we want to solve either the first or second equation for one of the variables. And since we want to make life easy for us here, if you have a y or an x like I have there, it's easier to either solve this equation for y or this one for x. It doesn't matter which one, it's your choice. So I'm going to take the first equation and I'm going to solve it for y. So if I take this equation and then solve it for y, I'll just subtract 2x from both sides, and I'll get y equals minus 2x plus 8. Now, what that allows me to do is that allows me to go back into the second equation, the other equation. Make sure you don't plug back into where it came from. Plug into the second equation, and that's where we're going to substitute. So I'm going to take that second equation. So instead of x plus 3y, I'm going to have x plus 3 times what y equaled from here, which was minus 2x plus 8 equals 9. And now I've simplified this to an equation with only one variable. And now just go ahead and multiply the 3 through. 3 times minus 2x is minus 6x, and 3 times 8 is 24. And if you take x and add it to negative 6x, you get negative 5x. And in case you're wondering where I got negative 15, I actually subtracted 24 from both sides. So 24 to get rid of this 24. So 9 minus 24 is negative 15. And then if you divide both sides of this equation by negative 5, you'll get your answer for x. So divide negative 5 into negative 5x, you get x, and divide it into negative 15, and you get 3. So that's x equals 3. Now make sure you don't stop here. That's a common error some students make. You still have to solve for the other variable. Now you can plug x into any of these two equations here and solve for y, but it's going to be easier to go ahead and plug it into this equation since you've already got it written in terms of y equal. So let's plug x into here. So when I plug x into this equation, I get y equals minus 2 times 3, which is minus 6, plus 8 is 2. So I know x is 3, y is 2. So that's the solution. And again, make sure you check it. Now I'll let you read through this one, but I wanted to show you an example of where I solved for x instead of y, just to show you can do it either way. So I took the first equation from this system and I solved it for x, and I got x equal y plus 3, and then I took the y plus 3 and I put it into the second equation for x, and so that gave me y plus 3 plus y equals negative 1. And then I just took that equation and solved it for y and got y equals negative 2, and then I plugged the negative 2 up here into where it says x equal y plus 3 to get my x value. So I got my y value negative 2, my x is 1. You can freeze the video and work through that a little slower if you want to. Here's a simple application problem that I wanted to show you. Suppose a concert is selling adult tickets and child tickets to a concert. Suppose a person buys 2 adult tickets and 1 child ticket for a total of $8, and a second person paid $9 for 1 adult and 3 child tickets. Find the price of the adult and child tickets. Well, since it says find the price of the adult and child tickets, that's going to be my unknowns. So what I'm going to do is I'm going to let x be the price of an adult ticket, and I'm going to let y be the price of a child ticket. Well, I know there was 2 purchases here, 2 adult and 1 child ticket, so that means 2 times the number of adult tickets plus 1 times the number of child tickets had to equal their total, their total they paid, which is $8. So 2x plus y equals 8, and so that gave me this equation. And then the second purchase was 1 adult and 3 child tickets, so 1x plus 3y must equal $9. That's a typo there. It should say $9. So anyway, that's the system of equations that we have. So 2x plus y equals 8 and x plus 3y equals 9. Now I sort of recycled what I had. This is actually the system we solved from number 1. So that's how I know the answer is 3-2. So the ticket prices were $3 per adult ticket and $2 per child ticket. And you can go back up here and look at this first one if you need to see how I solved it. Okay, let me show you this first problem here. This is a dependent system, but if you tried to solve it by substitution, here's what you'd have to do. You'd have to take one of the equations, and I took the first one, and solve for one of the variables. I decided to solve this for x. So I subtracted 5y from both sides, and I got 2x equals minus 5y plus 1. Then I divided everything by 2, so that gave me x equals minus 5/2 y plus a half. Well, then I took this x value and I plugged it in up here for x. So when I plug it in up here, I get 6 times negative 5/2 y plus a half plus 15y equals 3. Well, when I multiply 6 times negative 5/2, I'm going to get negative 15. So this is going to be 6 times this is going to be negative 15y. And then 6 times a half is plus 3. And then I bring down the 15y, and what happens is the 15y and the minus 15y is 0, so I just get 3 on the left as well as 3 on the right. So now I have an identity, 3 equals 3. So since I got a statement that's always true, then this point has infinitely many solutions. So this system graphically these two equations would be the same line. Now, I'm not going to go all the way through this second one because it's so similar to the first one, but there's one little difference. If you take this first equation and you solve it for x in terms of y, you'll get minus 5/2 y minus a half, and then when you plug that in up here for x, what you're going to get is almost the same thing. The y's are still going to cancel, but now we have minus 3 on the left and plus 3 on the right. So this is basically saying that the only way you could get a solution is when negative 3 equals 3. And since that's an impossible equation, negative 3 can never equal 3, then this system has no solution. Okay, pause the video and read this section on in the yellow here. And so it'll give you an idea about what revenue cost, fixed cost, variable cost, break-even point, and so forth is. And then when you're done, go ahead and start the video, and I'll show you how to solve an equation for the break-even point. Okay, so let's take a look at this example. Suppose a company sells calculators at a price of $45 each. The weekly cost for the company is $30,000 plus $25 per calculator. Find the break-even point. Well, the revenue is easy to get here because you're going to get $45 per calculator. So your revenue is simply 45x. Now the cost has two components. It has the fixed cost, which is $30,000, and that doesn't depend on the number of calculators. That's fixed. And then the variable cost is $25 per calculator. So your total cost is $30,000 plus 25x. Now, in order to solve for the break-even point, we want to find where the revenue function equals the cost function. So in essence, what we're doing here is we're doing a substitution problem. We're actually going to take here revenue equals 45x, and we're going to substitute that in for the cost. So we're just doing a simple substitution here. And when you do that, you'll get this equation, 45x equals 30,000 plus 25x. And then if you subtract 25 from both sides, 25x from both sides, you get 20x equals 30,000, or x equals 1,500. So that means we must manufacture 1,500 calculators per week to cover our cost, or to break even. And if we manufacture less, we're going to experience a loss. If we manufacture more, we're going to experience a profit. Now, if you want to know the answer to this, if you want to know the revenue that you're going to earn at 1500, I had to change that. I had the wrong number there. But 1500, then put 1500 into your revenue function. 45 times 1500 will be 67,500, and so that's your break-even point. That's the same thing you would get if you plug 1500 into the cost function as well. So at 1500 calculators, you're going to have a revenue of 67,500 and a cost of 67,500. One last thing I want to mention: if you were to graph these two on a grid, you would see that both of these would have a positive slope, but the revenue would start out below the cost function at x equals 0, but as x increased, revenue would slowly catch up to the cost function's graph. So you might want to graph those two on a graphing utility and just see how the graphs meet up with one another at the point 1500 and 67,500. Okay, again, pause the video and read this portion in the yellow that explains equilibrium supply demand, and then when you're ready, go ahead and restart the video to see me solve an example. So down here on this example, suppose we want to analyze the sale of a box of tea, where Q represents the number of boxes of tea in thousands during 1 week, and we have determined the supply and demand cost to be supply equals P equals 0.07 Q plus 0.76, and demand is P equals negative 0.2 Q plus 4, and we want to find the equilibrium point. Well, this is just another example of substitution. We're going to take what P equals from the supply equation and substitute it in here for what P is for the P variable in the demand equation. And so when I do that, I'm going to get this equation. And now to solve this equation for Q, I'm going to add 0.2 Q to both sides and then subtract 0.76 from both sides, and that'll give me this expression. And then when I add 0.07 to 0.2, I get 0.27 Q, and then 4 minus 0.76 is 3.24. And then when you divide by 0.27, you get Q is 12. So 12, and since it's thousands, that would be 12,000 boxes of tea. So if we provide 12,000 boxes of tea, then the consumers will consume 12,000 boxes of tea. At least theoretically, that's the point. Now, to set the price, just take this 12 and plug it back into one of these equations. So I'm going to plug it into this one. 0.0712 plus 0.76 gave me $1.60. So the equilibrium point is Q is 12 at a price of $1.60. Now, if you want to see this, you can see it on the grid here. Okay, so this line here is your demand equation, the graph of your demand equation. Notice as the price drops, notice how the demand goes farther out here. So the demand increases. But on the supply equation, notice that when the price is low, the supply is very low, but when the price increases, the supply increases. So that basically tells you the suppliers are willing to supply more if they can get more money, whereas consumers are willing to consume more if they can pay less money. And then you can see the equilibrium point right here at 12:1.6, where the two graphs cross one another. Again, pause the video and read this problem to save me a little bit of time, and then start it when you're ready. Now, basically, if you read this problem, in the supply, you're going to have 2 points given, 9400, 1.82, and 9800 and 1.94. And you can use those points to get the slope. And then once you get the slope, you can plug one of those points back in to get the y-intercept. And so once you have the slope and the y-intercept, you can get this supply equation. And on the demand equation, you do exactly the same thing, but you use the ordered pairs that you're given for demand. And then you get the demand equation. So that's how you find the supply and demand equation from a given points.